We now discuss the solution of a problem from the section Coordinate Geometry, and this problem is on the transformation of coordinates. This question has appeared in Joint Entrance Examination Main held on 27th July 2021 in the second shift. The problem is the point P with coordinates a comma b undergoes the following three transformations successively. A. Reflection about the line y is equal to x. B. Translation through two units along the positive direction of x-axis. C. Rotation through an angle pi by 4 about the origin in the anti-clockwise direction. If the coordinates of the final position of the point P are with coordinates minus 1 by root 2 comma 7 by root 2, then the value of 2a plus b is equal to. We are given four options. Option 1, 5. Option 2, 13. Option 3, 7. Option 4, 9. So we are given a point P with coordinates a comma b, and this point undergoes three transformations successively. The first one is the reflection of the point a comma b in the line y is equal to x, and then the translation through two units along the positive direction of x-axis, and then rotation through an angle pi by 4 about the origin in the anti-clockwise direction. And we are given the final position of the point P as the coordinates minus 1 by root 2 comma 7 by root 2, then required to find 2a plus b from the following four options. We first talk about the rotation of a point about the origin and the transformation of coordinates. That is how the coordinates of a given point will get transformed after the rotation of that point about the origin by some angle theta in the anticlockwise direction. Let P with coordinates x comma y be a point rotated about the origin by an angle theta. So x-axis, y-axis in the origin, and that is the point P with coordinates x comma y. Let phi be the angle that OP makes with the positive x-axis. This is the phi, that is the angle that the OP makes with the positive x-axis. And let OP be r. R is under the square root of x square plus y square. And in polar coordinates, writing the coordinates x comma y in polar coordinates, we get x is equal to r cos phi, y is equal to r sin phi. Okay. Now let q x prime comma y prime be the point obtained after the rotation by an angle theta. By further theta angle we have rotated, and this OP on rotation becomes OQ with the angle theta, and this phi will be theta plus phi from the positive x-axis. So this is there, and this is the angle theta, and now notice that OP is equal to OQ is equal to R. Why? Because we have rotated. On rotation the point P OP will be same as OQ, and OQ makes an angle theta phi plus theta with the positive x-axis. So therefore, x prime is equal to r cos theta plus phi. That is, r cos of theta plus phi is cos theta cos phi minus sin theta sin phi. So we have written that one. And r cos phi is x, and r sin phi is y. Then this becomes x cos theta minus y sin theta. Then y prime is equal to r sin of theta plus phi. Yes. So for sin of theta plus phi is sin theta cos phi plus cos theta sin phi. We have written here. And r cos phi is x sin theta plus y cos theta, because r sin phi is y. So now, writing in matrix form the new coordinates x prime, y prime, that is equal to cos theta minus sin theta, and second row sin theta cos theta multiplied by the coordinates of P, x, y. So that is the coordinates of the point with the coordinates x comma y will be transformed into x prime, y prime, and this is the relationship, and this is the matrix of the rotation. Matrix of the rotation, and this is the rotation of the point P x comma y about the origin, and the transmission of coordinates will take place as x prime by y prime when that P of x comma y is rotated by an angle about the origin by an angle theta in the anti-clockwise direction. So this is the formula which you have to remember. We now continue and discuss the problem in detail. Given that the point P a comma b undergoes the following three transformations successively. The first one is reflection about the line y is equal to x. So P a comma b is transformed into Q b comma a, because it is a reflection about the line y is equal to x. So the y coordinate becomes x coordinate and x coordinate becomes y coordinate. Agreed. Second, translation through two units along the positive direction of x-axis. So now Q b comma a is translated by two units in the positive direction of x-axis. Then b becomes b plus 2, and the a remains the same. Now rotation through an angle pi by 4 about the origin in the anti-clockwise direction. We now recall the just now derived formula, that is the old coordinates x comma y of the point P on rotation becomes on rotation by an angle theta in the anti-clockwise direction becomes x prime y prime about the origin. So rotation about the origin. So this is the formula what we have, and the xy is b plus 2a. So b plus 2a is not 2a, it is b plus 2a. And cos theta minus sin theta cos theta multiplied by b plus 2a. So there is no a here. So this is the transformation takes place. That is, this is the final one where theta is pi by 4, and given the final position is the minus 1 by root 2 comma 7 by root 2. This is the final position. So therefore cos pi by 4 minus sin pi by 4 cos pi by 4, that is the matrix of the rotation multiplied by the coordinates b plus 2a, and the final position is this one, minus 1 by root 2, 7 by root 2. So now we simplify and get the value of 2a plus b in the next slide. We have this one, the story so far. So multiply So if you multiply b plus 2 cos pi by 4 minus a sin by pi by 4, and the second row is b plus 2 sin pi by 4 plus a cos pi by 4, and that is the 2 by 1 column vector minus 1 by root 2, 7 by root 2. Equating the corresponding terms we get, and we want to find 2a plus b. Equating the corresponding terms we get b plus 2 minus a by root 2. Why? Cos pi by 4 is 1 by root 2, sin pi by 4 is 1 by root 2. And on the second one, b plus 2 plus a by root 2 is equal to 7 by root 2. Root 2 cancels, and we get b plus 2 minus a is equal to minus 1. b plus 2 plus a is equal to 7. That will imply b minus a is minus 3, right? b plus a is equal to 7 minus 2, that is 5, right? On solving, we get a is equal to 4 and b is equal to 1, and therefore 2a plus b, that's what we is required to find, and 2 into 4 plus b is plus 1, that is 9. Let's look at our options. Our answer 9 appears against option 4, therefore our answer is option 4. That is the discussion of the solution of the problem on the transformation of coordinates from the coordinate geometry. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.